In this video, we'll look at a nice, quick application of the trigonometric functions defined for angles that are not necessarily acute. So we'll first take a look at two different triangles, and then we'll try to figure out the area of those two triangles and see if there are any differences between the two. And we will conclude with a definition. So consider these two triangles. The one on the left, we have a height h, a side b, side a, and an angle theta. On the right triangle, we have an angle theta that's not acute. This angle is obtuse. We have a side a side b, and a height h. So in general, we know that the area of a triangle is 1/2 times the base times the height. Now, in the triangle on the right, that's a little bit more difficult to figure out, but we'll figure that one out. But let's start with the triangle on the left. So if we're trying to find an equation for the area, we know we have 1/2 and we need the base, A, and then we need to solve for the height. Fortunately, we can use our trigonometric functions to help us out with this one. So looking at our angle theta, we've got a side opposite that has h, the height, and we have the hypotenuse b of this right triangle. So with that in mind, let's say that sine of theta equals opposite h over the hypotenuse b. This would imply that b times sine theta equals the height. And that's our missing piece right here. We need b sine theta to be equivalent to our height. So we can just plug that in for our height. And we have a nice equation. A equals 1/2 ab sine theta. Now what I'm curious about is if we can find, for this triangle on the right, a similar equation. So again, we're looking at A equals 1/2 times base times height. The height's a little bit less obvious here, but we'll see if we can figure it out. So we have A equals 1/2 times little a times the height. Now this angle here, what angle will that be? That angle is 180 degrees minus theta. Since this kind of completes a half circle, half the degrees in the circle would be 180 degrees, and then we have to subtract from it the theta that we're given to get this acute angle. So now, taking a similar approach, we could say that sine of 180 degrees, or sine of 180 minus theta equals h, the opposite, over b, the hypotenuse in this case. So we're looking at this triangle. H equals b sine 180 minus theta. Now, what do we have to do with the 180 minus theta? This is a little bit tricky. So here's the interesting thing. Let me draw you a picture to make this clearer. If we have the top half of our xy plane, and I trace out some angle theta, that's theta. 180 minus theta puts us in the opposite quadrant, right here. That's 180 minus theta, right? Because we have 180 degrees, and then we just have to move back theta degrees. The cool part is that these both have the same y values. 180 minus theta is just the reference angle for theta. So we can say that h is just b sine theta. So both of these triangles' areas can be represented with the same equation. A equals 1/2 AB sine theta. So for the area of a triangle, the area A of a triangle with sides of lengths A and B with included angle theta is A equals 1/2 AB sine theta.